All right, SB. So, what do I have to do first in number one? Put it in what? What are you given? You're given a what and a what? A slope and a point. So if you're given a point and a slope, where do you think you should put it at? That'd be a great place to put it. So, I'll start you off. Y minus what? Yep, minus a negative 6 equals my slope, which is, and then x minus 4. Now what? What's the left side going to be? Uh-huh. What's the right side going to be? Uh-huh. Plus 24. Okay, last step. Subtract the 6 from both sides. So y equals negative 6x plus 18. There you go. See, you know what you're doing. Okay. Up to the next one. What are you doing first? What are you finding? Okay. Find the slopes of 16 minus 4 over 3 minus 1, which is going to be 12 over negative 4, which is negative 3. All right, so there's your slope. Which point are you going to use then? Okay, 1 and 4 then. So y minus equals x minus. Okay, so this side stays the same. What's the right side going to look like? You can stop eating goldfish till the end of the problem. And then what? How are you going to take them over? Add a 4. There we go. There we go. Okay, Hoover. What's the slope of the line on the left of number 3? Negative 4. Okay, what's the slope of the line on the right? We don't know. What do you have to do first? What do you have to do to find the slope? No. Uh-uh. Do those lines look the same? Put your hand down, close your mouth, you. No. What is by itself in this one? What do you think we need to get by itself in this one? There we go. Let's solve for y. So how am I going to solve for y? Yep, subtract 2x for both sides. So I have negative 8y equals negative 2x plus 16. Now what? Divide negative 8 by everything. Okay, so then now I have y equals, what's negative 2 over negative 8 going to be? Not your problem. What's 2/8? Okay. And 16 divided by negative 8? What's the slope of that line now? Okay, parallel, perpendicular, neither. Perpendicular, because they are negative reciprocals of each other. Questions? Okay, that was the new stuff we did on Thursday last week. All right, so last lesson before Christmas. Here we go. 5-7. We are doing this lesson today. We'll review. Next time I see you, you have a test the last day. All right, that's where we're at right now. Okay. So 5-7 is scatter plots. This is the last one for this chapter. Anybody tell me what a scatter plot is? Hand is up. Go ahead. Why was your hand up 4 times already? Do you have a question?
I lost it.
Probably plots that are scattered, like points.
Okay, scatter plot is a graph that relates 2 different sets of data by displaying them as ordered pairs. Okay? And then we have something called a correlation. Correlation is a relationship between the sets of data. All right, so scatter plot is going to be a graph. It's going to have a whole bunch of points on there. They might look like they go together. They might look like random, just all over the place. They're going to have some type of form to them. That's what a correlation is. We'll see in a minute here what the 3 different types of correlation we have are. This is one of those lessons too, guys. This is probably one of my favorite ones throughout the year to teach because this one is just super, super applicable. A lot of times, how many of you guys ever watch the news? Anybody? Okay. So if you watch the news at all, a lot of times they'll have stuff about stock market projections, and those types of things. What they do is they use things like a scatter plot. They'll take the data, they'll put it on a graph, and they'll see it over time to see what the trend is, whether it's going up, whether it's going down, those types of things. And then they use that to predict what it's going to be the next month and things like that. This is what a scatter plot is. This is what we're going to do throughout this lesson. Yeah. What's your question? You're different. All right, so scatter plots is a graph that relates 2 different sets of data by displaying them as ordered pairs, and then correlation is the relationship between the sets of data. So let's do correlation real quick. So correlation, we have 3 different types. First one is positive correlation. If we have a positive correlation, both your x and y are increasing together, and it's going to look something like this. All right, there's dots all over the place. Do they look like they're pretty much going uphill overall? Yeah, they're kind of matched up. You could draw a line through the middle of this, and it would pretty much show overall what's happening, right? Okay, so that's positive correlation. So as your y term is getting bigger, your x term is getting bigger as well. Okay? Negative correlation. How do you think negative correlation looks? Yeah.
Start at the top and go to the bottom.
Yeah, you're going up from high to low.
The Y is the line that's facing out, right?
Yep. All right, so this would be negative correlation. So as your y is increasing, your x is decreasing. Okay? And if you look at it too, if you look at the slope of your data, if it's a positive slope, it's going to be positive correlation. If it's a negative slope, it's negative correlation. All right, then the last one, no correlation. That's when it just looks like you have chicken pox on your graph. They're just kind of all over the place. Is there any form to that? No, they're just random. They're everywhere. There's no form to it. It doesn't look like it's going uphill, downhill, anything like that.
Never mind. Not a good question.
You've done. You made us get rid of the bad questions.
It's a good thing.
It's a bad thing.
All right, so let's make a scatter plot. So I'm going to give you some information here. All right, so we're going to graph the weight of a panda by its age in months.
Which one's Y?
We're going to graph the weight of a panda by age. Okay? Now, whenever you go to do a scatter plot, you got to do a couple things. One, you don't have to draw your full graph like you normally do. Okay? Big x, y axis. You only need like the top right of the graph. Okay? So usually if we go to graph something, we graph it like that, right? But we're only going to use this section, so we don't have to draw the rest of it for one. All right, second thing, you need to have a title to your thing. All right, so I'm just going to say weight of a panda. All right, you need a title. Either put it at the top or at the bottom, nice and big. Then you need to label your axes, your y-axis, your x-axis. Now looking at this, which one do you think's x? Which one do you think y?
The weight's the y, because the x and the y thingy.
There you go. Anytime we have a chart, we go x, y, don't we? So this is my x column. This is my y column. All right, so y, this is going to be weight. This is going to be age.
Wait, it's not weight is x. X is weight. You have a y. Oh,
Okay? So I labeled my two axes. Now, this is probably one of the tougher parts of scatter plots. You have to figure out what your scale on your axes are going to be. Okay? I could start here and just go 1, 2, 3, 4, 5 the whole way out through. And I can do the same thing here 1, 2, 3, 4, 5, right? But this thing goes from 1 to 10. So in reality, I could go 1 through 10. This guy goes to 66. So if I start to put a line every 1, I'm going to have a humongous graph, right? So you can do this in different ways. Maybe I want to do this by 2s and do this by 10s. That's perfectly fine. But you just make sure you write it down like that.
Is 1s by 10s good enough?
What?
Am I allowed to do 1 by 10?
Yeah, there's no right or wrong. Okay? Just use what it works for you. So I'm going to go 2s on the across the bottom. 2, 4, 6, 8, 10. And then I'm going to go 10s up across the right side. So 10, 20, 30, 40, 50, 60, 70. What?
how would you?
Okay. Now, just make sure that you have it labeled. Because if we have different number of lines and I'm graphing this, I'm going to have no idea what maybe you're graphing. Okay.
Just by looking at it, you can already tell it's a positive graph.
Why is that?
Because I did the first 2 coordinates, and it goes straight up.
Even if you don't look at that. Look at this beginning thing. What does it say? X and Y increase together. Is X increasing? Is Y increasing? There you go. All right, so let's graph it then. 1 is going to be about 2.5. 2 is at 7.6. 3 is at 12.5. Now again, I'm just kind of estimating where these guys would be, right?
Yeah.
They're not going to be perfect across the board. Okay, 4 is 17. 5 is 24. 6 is 37.9. 7 is 49, so all but 50. And then 8 is 54.9, so it would go up here, right about there. 9 is going to be at all but 60, and 10 is going to be at 66.2. So it looks something like that. Okay? So is that positive or negative correlation? It's obviously positive. Okay, it's obviously positive because it's going uphill, left to right. It almost makes a pretty good line, doesn't it? All right, it's pretty darn close to being in a straight line.
Do we have to write the points down every time we do this? Like if there's a graph right there.
The points?
Yeah.
It drew all the points, yeah.
Yeah.
You don't have to write that
No,
this is
I meant
like
I
417.
meant Drew.
That's- If you're gonna draw a scatter plot, then yes.
Ages 5 through 7, is that when a panda hits puberty?
I don't know.
It goes up bigger than the other ones.
And these are in months too.
Huh?
He's not even a year old at the end of this graph.
What?
More.
That doesn't matter.
I weigh more
Age
than
in months.
That's one pretty scary.
At the age of 1 month, I weighed more than 2.5 pounds. I was 11 pounds when I came out of the womb.
Questions on how we drew the graph, first off.
It's a bad story though.
What?
Will we be Friday to a graph?
No. Okay. Here's the next part. We have trend lines and predictions. So it's all well and good to make a graph, but we got to be able to use it for something. Okay, so we are going to have two things. Trend lines. Trend lines is a line drawn through the center of the points that shows the overall shape of the data correlation. All right, then we have two words, interpolation and extrapolation. Interpolation is an estimate within the range of the data. Extrapolation is an estimate outside the range of the data. All right, and you need to remember what those two are. Inter, inside. Extra is outside. All right, now, one big thing. People always mess this up on a trend line. It is not connect the dots. Okay? You might not actually touch any single dot. It is not connect the dots. It is one single straight line. That is a trend line. We're also going to use this as a line of best fit as well.
I have coffee in the morning.
All right, we go with these words?
No.
No?
Yeah.
All right, so I'm going to flash back to the one we just did. And if I want to draw a trend line, again, it is not connect the dots. My trend line should look something about like that. Okay? It's pretty much through the center of all the points. If you look at it, I have what? Probably 2 right on it, about 3 above, about 4 below. Okay, that's a pretty good estimate of straight through the center of the data. So it's one straight line as much through the center as possible. All right? Now, as you go further in your math career, you're going to do something, it's called the line of best fit. Okay? The line of best fit, this is what we're going to use for our predictions and those types of things. Now, if I want to do the true line of best fit, I would need to put this in a graphing calculator. Okay? You put it in a graphing calculator, you do something called linear regression. Linear regression is calculator will figure out basically the distance from your line to every single point and how to make that distance the absolute smallest possible. Okay? To try to do it by hand with 10 points, doing something called the least squares method, we would probably take up this entire board. Okay?
That's easy.
Yes. All right. So we will not do that. What we're going to do, we're going to estimate the line of best fit. And to estimate the line of best fit, we're going to do it this way. This graphing by line of best fit by hand. So you're going to graph the scatter plot. You're going to draw a trend line as centered as possible. Then, to make the equation of the line, we're going to pick the 2 points closest to the line and find the equation of the line for those 2 points. We've done that probably 50 times now between in class and on your homework. Take 2 points, find the slope, find the equation of the line. All right? These are not always going to be pretty. Sometimes you're going to have some decimal answers, but believe me, if we did linear regression, they'd be really crazy answers.
Is the line
You have 2 points, then what do you do first? Find the slope, right? Y2 minus y1 over x2 minus x1. That would be your slope.
102 points.
line?
You guys not reading?
Where's the line?
You draw it.
Right now we get.
Look at the steps. You graph it. Then you draw a trend line. And you draw your as center as possible.
Are you talking about this?
Then you pick 2. We didn't do an example yet. This is your
Oh.
steps to how to do it. All right, so draw your trend line through the middle of the data the best as possible. And then pick the 2 points closest to your line. Find the equation of the line through your 2 points. Now, we might all have slightly different answers. Okay? If one person picks the 3rd and the 8th point, the next person picks the 2nd and the 5th, because based on the way they drew it, you might have slightly different, but it's fine. All right, one of you might have a slope of 2.5, the other might have a slope of 2.75. That's okay. All right?
I would pick the 1 and the 6.
We don't have an example yet.
What did you see page 5 and 6 for the panda? You said the panda keeps growing between 1983.
Because if you look at 5 through 7, there's a bigger increase than the other places.
Oh. I thought you were talking about
No.
Maybe you just ate extra that month.
What?
Maybe you just ate a little extra that month.
Did you know bamboo is like really, really bad for the panda?
That's why they're fat.
No, like there's like no nutrients or anything in them.
All right, are we done with these notes yet?
No.
And they barely know how to reproduce. That's why they're so extinct.
I'm just giving Lucas extra time to finish.
All right, so let's do a whole one. Okay? So we're going to do several things with this. One, we're going to graph it. 2, we're going to define trend line, line of best fit. We're going to talk about the correlation. Then we're going to make some predictions. Okay? So, first off, what's the title of my graph going to be here?
How much
What is the title of my graph going to be?
calories and fat and selected fat?
Calories and fat Say in fast food. That work? I just kind of abbreviate a little bit. All right. Calories and fat in fast food. What's my X column? Or fat in grams. What is my Y? Okay. So this one's a little bit different because we have different scales. We're going from 6 to 36. In the X column, we're going from 276, actually 220, to 633 in our calories one. All right, so how do we want to set up our scales? Let's look at the fat one. What do you want to do in the fat one? Do by fives? All right, I'm good with that. So 5, 10, 15, 20, 25, 30, 35, 40. Go with that? Yes.
For the calories thing, how it goes down, what would the graph be? Would it be,
Well, let's graph it and see what it looks like.
would it be negative?
All right, so we have 220 to 600. How do we want to space those guys out?
550.
By 50s?
No.
You start at 250 and get 300. I wouldn't get
Want to go by 100? Okay. Okay, so let's go 100, 200, 300, 400, 500, 600. One's a little bit over that.
There was 700.
Okay. So from there, let's go ahead and graph them. So the first one is at 6, 276. So 6, 276 would be about there. 7 would be at 260, so it's slightly below this. All right. 10 is at 220. It's 10, 220. So it almost looks like it's going down to start with, doesn't it? All right. So then 19 is 388. So 19, 388. 20 is 430. Okay. 27 is 550. And then 36 is 633. So now all of a sudden, other than those three at the beginning, at the end of the day, they're pretty close together though, aren't they? All right, so overall, is this a positive or negative correlation? This is going to be a positive correlation. Okay, it's going to have a positive correlation. All right, so let's draw our trend line. Try to go as much to the middle as possible. So I'm going to say that looks pretty darn close to the center, doesn't it? We got 2 on it, three below, 2 above. It could maybe be down just a whisker, but no. At no point does it have to go through 0. All right, so I have it through the center. So I'm going to look at this. Looks like that point and that point are both touching my line. Would you agree? All right, so those ones would be the best descriptors possible. So that would be 7 and 36. Okay, so those are the 2 points I'm going to use for my line. I'm going to use the point 7, 260, and I'm going to use 36, 633. Okay? First thing you have to do to find equation of a line through 2 points is to find the slope. It's the slope.
Y minus Y.
Yep, 633 minus 260 over 36 minus 7. So somebody grab a calculator.
What's that be? 433 over 20.
They already got it.
No, we'll do it, Lucas.
About
433.
373.
260.
Yep.
Oh,
You guys.
So 373 over 29. Now divide that. Give me a decimal on that one.
12.863.
12.86.
12.86.
So we'll call it 12.9. We go with that? Okay, so we'll call our slope 12.9. All right, so let's use a point. Let's use this point and our slope. So y minus my y term equals my slope, x minus my x term, which is 7. All right, so I'm going to have y minus 260 equals 12.9x. What's 12.9 times negative 7? 12.9 times 7.
90.3.
Okay, then I have to add a 260.
350.
No.
130.7.
What? 250. Wait, is that negative 90?
Yes.
Oh.
170.7.
Uh-huh.
Yeah. What was that?
Okay, so 170.7. So that would be my equation of my line of best fit. Okay? So y equals 12.9x plus 170.7. So what's my slope of that line?
12.9.
What's my y-intercept?
170.7.
Yeah. Now looking at this, if my slope is 12.9, let's just talk about that in theory. So in theory, what does that mean? If my slope is 12.9. So if I have,
For every one, it's 12.9, right?
for every one what?
One number. One G.
Every 1 gram, correct. There we go. Every 1 gram of fat that my food goes up, that means I'm going to gain another 12.9 calories. Okay? What's your slope? Okay. It's your change in y over change in x. So every 1 gram it increases. Every one that your x increases, that means your y is going up 12.9. So every 1 more gram of fat, you have about 12.9 or 13 calories. All right? Now, let's make a couple predictions. So if I tell you that a Big Mac has 22 grams, you guys have that? Do you have that equation and stuff written down? Like that work on the board? If I erase it for more room, you all right? Okay.
I mean, that equation.
So I'm going to rewrite this up top here.
Got a Big Mac.
All right. So that is the equation for my line of best fit. Now what I want to do, I want to make the predictions. So I'm going to say a Big Mac has, how much did I say? 22? 22 grams of fat. Okay, so it's 22 grams of fat. How many calories do we predict that it's going to have? So how do we figure it out? Yes. Over. Because you're putting 22 in for what? How about in for x? There we go. So I use the line I just found. That's my line for my predictions. 12.9 times 22 plus 170.7. So what's 12.9 times 22? 283.8. Now plus 170.7. 454.5. Okay, so if something has 22 grams of fat, we predict it's going to have 454.5 calories. Okay, so let's just look at it on our graph real quick. 22, we're saying at 22 would be around there. Now, if I don't want to find exact, if I just want to use my graph to estimate, well, looking over there, it's pretty close to 450, I'd say. All right, so you can use your graph to estimate, or if you want to find the exact number, then you just use your equation. Okay, this is called interpolation. Okay, that's interpolation because that would fit right in here somewhere. Okay, that's inside the data set. All right, so now we found that the Big Mac had 22 grams of fat. So say we want the Big Mac meal, and the meal has, fries and a drink with it. So if I have the whole meal, and I'm going to say that it has 44 grams of fat. Okay, so now, is this outside of my range of values on my graph?
Yeah.
Yes, it is. So now this is called extrapolation. Do the same exact thing. Use my equation of my line. So 12.9 times 44 now plus 170.7. What's 12.9 times 44? 567.6 plus 170.7. What's that going to be? 730.3? 738.3. So then that meal has 738.3 calories if it has 44 grams of fat, based on everything we have here. Based on the information that we have, we're using that to make our predictions. Okay, we made our scatter plot, drew our trend line, used it as a line of best fit, found the equation of the line, then made two predictions off of it. Okay, so there's a lot going on from one little chart here, isn't there? Okay, there's a lot going on. But I mean, like I said, I think this is pretty cool stuff. This is, again, how you make predictions. This is how they make estimations to set betting lines and those types of things in Vegas. When you're betting on the NFL game or the NBA game, those types of things. Look at the over-under. You guys know what the over-under is? No? Okay, so every time in a game, there are going to be two predictions. One is going to be the money line, which is going to be, say, Penn State versus Michigan State. Okay? So last week, I think it was Penn State -3. That means Penn State was favored to win by 3 points. Okay? That's the money line. Then the over-under. The over-under is how many combined points are going to be scored in the game. So maybe the over-under was set at 63. So you could bet over or under that. If you could bet that more people, they're going to score more points than that or less points than that. They use trend lines. Okay? They're going to predict how many points Penn State scores on average. They're going to predict how many points Michigan State scores on average. They'll add them together and put it in there. Maybe add a few more factors in. But they would do this type of stuff. They would draw a trend line. They would make a prediction based on a scatter plot type item. All right? So, here we go. Here's another one. All right? I'm going to help you get started with the graphs, but I want you to, this is how much people spend for recreational activities. All right? Now, what I'm going to tell you to do here is for the years, instead of putting 1993, 94, and so on, just use the last number. So 3, 4, 5, 6, 7, 8, 9, 10. Use those. And then on the other side, whatever you find good. If you want to go by hundreds or whatever for the dollars. Okay? So I want you to do a couple things. One, I want you to make a trend line. Make a You're going to make a scatter plot. Okay. 2, draw your trend line. 3, find the equation of your trend line. And then I want you to predict for 2005. Does that make sense? Okay, so I'm going to give you some time. So I'm going to give you probably, I don't know, close to 10 minutes here to Here, I'm back. All right, we're live again.
Yellow.
So the first thing is you can do the actual years. You could do the years after 1990, something like that. What do you guys want to do? The actual years, or you want to? What did you do?
1993, 1996.
So you actually, I'm saying put the axis, the draw. You just want the
Wow.
actual years on
Let's
here.
go
I
from
went like 2
All right, so looks like most people did this. So let's go. We'll say this is 90, 92, 93, 94, 95, 96. Wait, 92, 4, 6, 8, 10. All right, I'll just keep going. 92, 93, 94, 95, 96, 7, 98, 99, 2000. All right. So I just did every one, right? 93, 94, 96, 97, 98, 99. Nope, we're good. All right, so then dollars. We have to go up to all but 600, right? So you just want to go by 100? Okay. So 1, 2, 3, 4, 5, 6. Yeah. All right. So then I need my graph title. So I'm going to call this expenditures. All right. This is the year. And this is the dollars. I'm just going to cheat a little bit and just put dollars on. Okay. All right. So in 93, I'm at 340. All right. In 94, I'm at 369. 95, I'm in 402. 96, I'm at 430. Right there. 97, I'm at 457. 98, I am at 489. 99, I'm at 527. And 2000, I'm at 574. Looks like that. Everybody have a graph that looks something like that? Okay, first off, it has a positive correlation. Good. All right, let's draw a trend line. Yeah. So I'm going to use this guy and that guy. Does that work for you guys? Okay. So that would be 94 and 2000. Correct. All right. So first one, y is going to be 574 minus 369. I'm going to need somebody with a calculator. Over 2000 minus 1994. All right. So on top, I'm going to have 574 minus 369. 205, and then 205 divided by 6. So say 34.2. Okay, so I'm going to use that one of my points. I'll just use this point. So y minus my y term, 574, equals my slope of 34.2, x minus my x term. Okay, distribute. So y minus 574 equals 34.2x. And then what's 34.2 times 2,000? What?
6,820.
68400.
That's literally what I
6,840 and 4? 40. Point what?
68,400.
Yeah, put another zero on there, Buck.
Exactly. Okay. All right. And then I have to add the 574 over, right? Equals 34.2x. Missed a number somewhere. Stop. Why is that coming out so negative? Are we good? Minus. All right, so what's 68,400 minus 574?
Nine, 5, 7, 4, 6, 7, 8, 2, 6.
5, 7. And then what?
8, 2, 6.
No, it's 6 on 5.
6, 7,
6, 7.
8, 2, 6.
Mhm.
Okay. Now, 6.
67.
All right, so then I plug that in. All right, I plugged it into my equation, so then I'm going to have, I want 2005, so I plug a 2005 in. Y equals 34.2 times 2005 minus 67826. What's that going to be? Calculator. You just gave them all to me.
34.2 divided by 2005. 7, 8, 2, 6. 745.
745. So 745 billion dollars is what we expect. Based on my chart, does that sound about reasonable? Yeah, it's going up about, $100 billion every 3 or 4 years, right? All right, I think that sounds reasonable. Now, again, your thing might be 25 if you pick 2 other points. All right, I saw someone that had like a slope of 25 here. Well, if maybe I drew my graph a little flatter and I used this point and this point, that could be true.
I have a slope of 30.
So you're right there. All right, what was your slope?
42.
42. So you were a little bigger. What were yours? What was your number right here? 34. So you're right there. How about you? 28, right there.
With the y-intercept,
What's your slope?
29.
29. What was your slope? What was your slope?
I already told you.
Put down. What was your slope? 40?
30.
30? Okay, so we are right there. It's going to be close. All right. Now, what's your question?
Would the y-intercept be the same?
The y-intercept should be roughly the same. It's going to be ballpark. Now, what's going to happen, though, guys, if you used a different number set for here, all right? So, if, say you just used a 1, 2, 3, or 4, okay? Or you actually made this into billions. Your thing might be a little bit different. Now, looking at this graph, too, it doesn't look like my y-intercept is going to be 0, does it?
No.
All right. But also remember, my x-axis is already out to 2000. So 0, 0 might be over here somewhere. You know what I mean? So that's why it made me even stop and think about it for a second too. I'm going, wait a second, how the heck do I have a negative y-intercept? Well, this isn't a true 0, 0 here. That's why. Does that make sense? Okay, so you might get some numbers that look a little goofy, especially on your y-intercept. But if you did it right, you're in good shape. Okay, and again, make sure I've seen people make this mistake too. So sometimes people go, all right, years after 1990. Okay, if you go years after 1990, you'd have 3, 4, 5, 6, 7, and so on. Well, then they use that for their slope. They use that for their equation. But then when they try to predict 2005, they put in 2005. Well, based on the way you have it set up, you should have put in 15. See what I'm saying? So make sure whatever you use for your units on your x-axis and your y-axis, then we're going to be, make sure you're using the same ones. Okay? So for homework-wise, there's going to be, I think there's 2 assignments I'm popping up for you. Okay? In theory, 1 for today, 1 for tomorrow. Okay? neither one is going to be a lot. I think the book work is going to be, here's a picture. What do you think about this? All right, what's this correlation look like? It's like this was a full encompassing question. I'm not going to give you more than 2 or 3 like this. You got me? All right, because if I give you 10 of these full problems, it's going to take you 45 minutes to an hour. All right, with SP's attention span, it would take him 6 hours. But I won't do that to you. So what we're going to do, so then come Thursday, all right, on Thursday then we will go over this stuff, right? Thursday we'll go over this stuff, then we'll start reviewing for your test. All right, your test is going to be the next week, that Monday, Tuesday.
Wait, when's our position work due? Is it due Wednesday?
Due Wednesday, just like normal. All right, any questions? I figured you'd have one.
You record tomorrow too.